Hi students, it is the second day of 7th lesson from science section A, that is lenses. Last period we have discussed more information about what are the rules to draw a ray diagram. The first law or first rule we have discussed, the line or the incident ray which is parallel to principal axis, after refraction it passes from focus. Second, if the incident ray is passing through the focus, then after refraction it go parallel to the principal axis. And the third rule we have discussed, if incident ray is passing from optical center, then it will not change its path. That means no deviation or refraction we are getting, it will travel with the same direction. Now, within this lecture, we are going to discuss how many images are what are images formed by convex lens for different position of an object. See, this is the convex lens. It is a double convex lens. Then this one is a principal axis. Principal axis is an image line passing through the both the center of a curvature. Then this one is a focus. See, this distance is called as a focal length. The distance in between optical center and the focus is called as focal length. So this distance is O to F1. And this distance again we having the same distance because focal length is a half of radius and that is center of a curvature. So it is 2F1, half of that is F1. Like this also. Because it is double convex lens, this is F2 because second focus. And double of that one is 2F2. So what are the factors we having? First we are having 2F1, then F1, then optical center O, then F2 and then 2F2, and this total is line indicating principal axis. Where we can keep this object now? The first position, that is away from the lens, far away from the lens, that is called as position of object at infinity. That is the first diagram we are discussing. Second one, if you are going to keep close to this one, then it's beyond 2F1. Beyond 2F1 is the second position. Third, exactly at 2F1. Then if you move that object towards the lens, it is in between F1 and 2F1. Then exactly on F1, that is at focus F1. Then in between optical center and the focus, or F1 and O. These are the 6 positions of object, and because of 6 position, how image is forming, that we are getting. See, if imaging forming towards the right side of the lens, that means in the real world we are getting that image, then that image is called as real image. Really we are getting image on the screen, or the image which we get on the screen is called as a real image. And if image is towards the left of lens, that is towards the object, it is called as virtual. From the principal axis, if image is upward, then it is called as erect image. And if image is downward, then it is called as inverted image. These are the nature and position and the size of the image, information about it. Now we are discussing the first part, the object which is at infinity. Keep it in mind. When object is at infinity, all rays are parallel to each other. That means rays comes parallel from the object which is at infinity. So the first object, the name of that object is AB. That is, A is the head and B is the foot of that object. Then all rays which are coming from that object as parallel. The object is at infinity, rays are coming, that is imaginary, we are considering this rays now. Because dot line indicates imagination, then we are considering continue lines. This is the first line. And from this lower part of object, now the rays are parallel. See now, the first rule, when ray is parallel to principal axis, after refraction or refracted ray passes from the principal focus. So it will bend down and after refraction it will come down, passes through the focus, and here is also it also passes from the focus, and these two rays are meeting here exactly on principal focus at f2, and this is very small one, a tiny image we are getting, and that image is of this object AB. Then where we have placed this object? Object is placed at infinity. Okay, what is the position of this image? See, image is at 2f1, that is focus. So position of image is at focus. What is the nature size of an image? Very small. Because of this very small, can we get here point image? And how is it? It comes towards the right side. In the real world we are getting this image. So image is real. Then upward side will go down and downside will go up. That means ulta, that is inverted. So how it is? When object is at infinity, image is at focus. How is the size of image? Point image or diminished image. And what is the nature of image? Real and inverted. What is the example of that one? See, magnifying glasses is an example. Maybe you have played with the magnifying glasses and you managed to burn the piece of paper. Sun is at infinity. Rays are coming parallel, and when these rays are falling on or inserting in the magnifying glasses, they will converge, and after converging, very small point image we are getting on the piece of paper, that is the image of sun. And if you hold it continuously as it is, because of the heavy sun rays, the paper starts to burn. So what is the example of that one? Magnifying glasses. What is the second one here? See, beyond 2f1. So this one is a 2f1. This one f1. It is O. Then this one is a f2, and here it is 2f2. Now object is beyond 2f1. So this is A and this one is a B. See, two rays are there. One ray is parallel to principal axis. Okay, how it will pass? It will pass through the principal focus. And second ray which is directly from optical center without any deviation. The ray which is passing directly from optical center without deviation, it will pass like this one, and these rays will meet here. As rays are meeting here, definitely there is a formation of image here. Head is downward, and so this one is a image. It is A, so this one is a A dash. This one is a B, so this one is a B dash. So see, where is the position? Position is beyond 2f1. Then where is the image we are getting? Image we are getting in between f2 and 2f2, in between that. Object is little larger, but image is little smaller. So smaller image we are getting. Again we are getting in the real world, that is towards the right side. So image is real and upright, here downward, so inverted. So what is the conclusion? When object is beyond 2f1, image is between f2 and 2f2. Image is smaller than object, and nature of image is real and inverted. What is the example of that one? Camera. Suppose this is the lens fitted in the camera. You are standing in this side. The person who is standing far from you, that is beyond 2f1, but within the camera or within the mobile, you are getting that person smaller or not? We are getting upright images in camera, or we are getting the upright images in mobile because of double lenses. First ulta, and ulta's ulta, that is again right image we are getting. Third is at 2f1. See here, this is the 2f1. This one is f1, that is object. here it will be having F2 and here we having F2 and we are having 2F2. The first ray which is passing here, see, the first ray is parallel to principal axis. After deviation it will pass through principal focus, that is the first ray. What about the second one? See, second. The first ray is parallel, but here now it is passing through optical center, and so it without deviation it will pass straight, and because of passing straight here we are getting this image here. See, this one is image. Where exactly image is at 2F1. Here the side is A, this one is B. So A will come down, so it is A dash, and this one is a B dash. So see, how is it? Object is at 2F1. Then image exactly we are getting at 2F2. Then what is the size of object? The same size we are getting here. And then nature is real and inverted. The fourth point is here, when object is between F1 and 2F1. See here, it is F1 to F1. Optical center O. This one is F2, and here we having 2F2. The object is placed in between F1 and 2F1. The first ray will pass parallel to principal axis. See, this ray is parallel to principal axis. After refraction, the refracted ray will go through the focus. Then again one line is there. Which one? See, from the optical center, the line which is passing on incident ray, which is passing from optical center, it will without deviation, it will go straight. And as it is going straight, it will meet here. See, and here we are getting image. This much image we are getting. This point is A, here B. So A will come down, so it is A dash, and this one is a B dash. So where we have placed this object? Object is placed in between F1 and 2F1. Image we are getting beyond 2F2, beyond 2F2. Then again, what is the size? See, object is little smaller, but we are getting that image little larger images we are getting. And again, towards the right side in the real world, so it is a real and inverted ulta. So where this principle we are using? We are using the projector. Within the projector or a cinema hall, the film is very smaller, but on the screen we are getting the large images, but not here. If you keep it ulta, you will get that upright. The fifth point or fifth position is object is at focus, that is F1. See, optical center F1 to F1. Now object AB has placed exactly at F1, that is focus. The first ray which is parallel to principal axis, we are considering the two rays, incident rays coming out from the top of that object. Definitely after refraction it will pass through the focus. See, it is passing through the focus. This is the refracted ray, and here the end point. Then second ray which passing through the optical center. When ray is passing through the optical center, it will pass without a deviation. When it is passing without deviation, this is an incident ray, it is a refracted ray, and pass like this. See, if you observe these rays, it seems parallel. That means, as parallel means what? Maybe they will meet at empty, that is infinity. So as they are meeting at infinity, definitely image will form at infinity. As it is going downward, the distance in between the principal axis and the top goes on increasing. That means image will be much larger. So what is the conclusion from this? when object is exactly at 2f1, definitely we are getting the image at infinity. Then how is the size? Larger size or very large size we are getting, but again it is towards the right side. So real upside will go down, that is inverted. So what is the conclusion? When object is at focus, image is at infinity, image is very large and nature is real and inverted. This point we are using in collimator. See, this is the example of this one. Collimator means the small rays to get parallel beam we are using. Have you seen rifles or the gun on which that machine has used to get the parallel rays to get the target? That machine we are using such kind of thing. This is the sixth point we are discussing when object is between F1 and O. See here, this one is a lens we have created here. This is the lens. Object we have kept it in between the optical center and F1 or F1 and optical center. Object is placed here, A and B, that is the object. The first ray will pass through the optical center. As it is passing from the optical center, rule number 3, without deviation it will pass. So it will pass like this one from the optical center, and as it is passing from optical center, it will not meet. Why? Because see, this is a ray which is parallel to principal axis, but after refraction definitely it will pass through the focus. But as you go further, these rays are expanding or diverting from each other. That means definitely they will not meet on this right side. So some imaginary lines when we extend this line backward. See here, we are extending these lines backward. We are getting one amazing thing here. That is the first ray, and the second ray that is also extended backward. We are getting these lines will seems to meet at this point. So definitely they are meeting here, and here we are getting the huge image. The rays are coming out from A, so A dash, that is the head here, and B dash is here. See, this is the ray diagram, but what is the condition here? When object is in between F1 and O, then image we are getting on the same side of the object. Within this 5 condition, we were getting the object towards the right, image towards the right side. So real images we are getting. But now, when imagine this image, real rays are meeting. But here, the rays which are dot lines, that is imaginary rays are meeting. So definitely, we have to imagine that object there. And this one is a virtual. So what is the nature of the image? Image is virtual. As image is virtual, again upright erect image, head is up. So same as the object we are getting the image. So what is the conclusion? When object is placed in between optical center and focus, or focus or optical center, we are getting that image on the same side of the object. How is the image? Image is very large, and nature of image is virtual and erect.